Good morning, everyone. My name is Kyle Escamilla, and I am the training coordinator for EandM. Thank you for attending our webinar today, Safety in a Snap, Compact Protection and Precise Detection with SICK nanoScan3. After the webinar this morning, we'll be doing a short Q&A. Please type any questions or comments into the Q&A box or the chat, and we will get to them at the end. Now I'd like to introduce your presenter for today's webinar, TJ Singh. TJ is a product specialist here at EandM. Good morning, TJ.
Hey, thanks, Kyle. All right. Thanks everybody again for joining in. So the topic is safety in a snap. My agenda is pretty straightforward. I'll just share a couple of slides to just get started on and talk about some of the hardware benefits of the nanoScan3, and then talk about some applications where it is used, and finally jump into the software demo where we'll spend majority of time. And yeah, that's pretty much it. So for nanoScan3, I hope you guys are familiar with it. If not, I do have a small image of how these things work. So ultimately, it's a safety scanner. Think about a LiDAR. Now, what is a LiDAR? So LiDAR works on time of flight technology. So in time of flight, what happens is that think about a small sensor that sends a light pulse that hits the object, and then that light pulse comes back after hitting the object. Now, since we know the speed of light, we can calculate the distance of any of that object in the environment based on that formula where distance is speed divided by time. And then since we know it's going to be going there and coming back, so we know there's a factor of 2 there. And that's how you calculate the distance. Now, what happens if you put this technology on a structure that is spinning on its axis? Then essentially you're able to grab a whole lot of data points on a 2D plane. And if you see this small animation, you will understand. So we are creating this entire data mapping in a way where we are getting everything back. And hence we are able to know wherever anybody comes into this environment, and we can trigger a safety stop based on that. Now that's how LiDARs work. And that's the core principle of the nanoScan3 as well. What makes nanoScan3 really special, I would say, is firstly the compact size. It's super small. The height is roughly 3 inches, perfect fit for those tight applications, especially AGVs. Then you have the safe HDDM technology, which is like a SICK proprietary technology, where we get a lot of data points and we are able to avoid any kind of false shifts, even in difficult environments where conventional scanners typically false ship a lot. My favorite is the user friendliness, so which we will also see in the demo. It's super easy to use the software, highly intuitive, doesn't take a lot of, there's not a big learning curve to get started on it. And then there's also a small display where you can see if there's any kind of an error happening for a quick fix. You also have smart integration. Essentially what that is if you want to keep it simple, you can use a basic IO system plug that comes with the scanner and connect it to a safety relay and get it up and running. Or if you want to talk it over field-bus protocol, then we do support with the Ethernet IP SIP safety protocol as well. And lastly, we also have core and pro variants. What that means is if you have a basic application, you can use a core. If you need a whole lot of dynamic field switching, generally required by AGVs and complex applications, then you can use the pro variant, where if you can see here, you have 128 fields and 128 monitoring cases. So you can switch between all of them. Applications, so where would you use that, right? The most popular thing for the nanoscan I've seen is a mobile platform. So be it AGVs, AGCs, any kind of this mobile platform is perfect, since the size, again, it's just 3 inches in height, highly compact, perfect fit. And The beauty about the system is you do get measurement data back, so you can also use it for navigation. So saves you on cost, and you can use safety and uh, measurement data, sorry, in the same hardware. Apart from that, it can always be used for the common safety scanner applications, which are the stationary ones, right? Hazardous area protection. So conventionally, people have used safety mats, right? But safety mats being mechanical fault out a lot of replacement is needed, and these are a perfect fit to replace that. Now, access protection. So if you can see in the image in the center, like if you have a cell where you want to have flexibility of product coming in and out, but you don't want people accessing it, you can use some access protection there, and also for point protection. So now typically these applications generally use light curtains, but now with the nanoscan 3 you can dial it down to a resolution of 20 millimeters, which means you can do somewhat finger protection, which generally a light curtain does. And without actually having a sender and a receiver separately, you can just have one small piece of hardware doing all that for you. Uh, yeah, so in terms of accessories, I do want to highlight there are really cool accessories that come along with the scanner. So we have some software accessories. So you can see we have ROS drivers, as well as a bunch of C++ libraries to get you that measurement data. Then we do have something called virtual groups. What that does is if you have a whole bunch of these safety scanners and you want to configure them together, where you might have like 4 on different spots, but they might interact with each other, then it makes much more sense to get this piece of software, because you can put it on our safety designer platform and configure everything together. And then there is no confusion of how to properly set the fields. And then we also have something called SLS visualization that simply allows you to uh, integrate the visualization feature into your SCADA systems like WinCC. Right now, it's for our other scanners like microscan 3. And then in terms of hardware, we do have something called alignment bar. So if you're putting it on a certain structure, you want to make sure the plane is right. You can use this. It basically reads the IR rays from the scanner and shows you where exactly your plane is set. Then we have something called Flexi Compact, which is more like a safety controller. If you have somewhat a complicated application, you want to put some logic in there, you can put this piece of hardware. And if we get time today, I can still do a quick demo on that as well. And then sensing cam. So this is what I really like right now. It's the newest product that SICK has come out with. It's basically a event monitoring camera. Now, what that would do for you is if there is any kind of a trigger in the environment where the scanner sees something, and you want to know exactly what happened at that particular time, right? If that is happening a lot, maybe you want to monitor that. You can use this small piece of hardware. It's this small, and if you can see in the camera, and it's 5 megapixel, talks industrial protocols, has 6 GB of memory on board, so you can record like 40-second clips at a trigger of any of those safety infringements. You can also use it for snapshots, so instead of video recording, you can do that. And it also provides live feedback data, which you can use as a CCTV camera, I guess. All right, that's all for the slides. Let's jump into the cool stuff. Let me pull the software in there. Uh, all right, so essentially, this is how it actually looks like. So if you're not familiar with the SICK Safety Designer platform, this is your programming window, but for the ease of demo, I already added everything in there, but this is what you would see. And if you search for a device, it will show you what it is connected to right now. And once you see it, you can always drag it in here, which I did. And once you double click on this, you will get this window, which you're seeing right now. So I did mention in the very beginning, right? The beauty about our hardware is the software itself, which is highly intuitive. And I'll show you how. So it's a top-down tree approach. Like you can see, everything is listed in a nice tab format. First is overview. And all you got to do is go top down. So now overview shows you all the different part numbers, if the device is verified or not. Next thing is the hardware. So now we do have a whole lot of different variants. This just helps you see what you're actually connected to at any point of time, and also gives you the part numbers, which helps you if you want to replace anything. Next comes configuration. This is where we spend most of the time. So readout is you're pulling out the data from the device. You can set identification for project names and stuff. If you have multiple devices, it does make a lot of sense. Then we have application selection. So now, obviously, this device can be used on a stationary format as well as on a moving platform like a mobile robot. And hence we have these two selections. They just internally help the system do better calculations. So that's why we set them. And then you can have your normal or upside down configuration for the display. And that also is a really nice, unique thing about the scanner, the design of it. If you turn it and put it upside down, and that's how customers like it a lot, because the optic does not allow the dust to stay in there and help, just like the dust can fall off it. And hence, once you do that, you would prefer to do it upside down here, so you can still see all the diagnostic data. Once you select that, you come into what we call monitoring planes. This is where you are gonna define the type of application you're using it for, and it's also represented by nice graphical pictures here. So if you see, first safety task is hazardous area protection, where somebody might walk into a certain area, which again requires horizontal area protection, right? Uh, and then if you're doing something different, then I showed you those examples, right? If you're doing access protection, now instead of walking into something, we are going to put the scanner tilted so that it can create like a virtual wall, which is represented here. And then last is obviously the point protection, which I told you can do finger guarding with it as well. So once you decide on what you're going to do, for my demo application, I'm just going to do area protection, where I'll show you how if I get into the safety zones, what happens, and what other tools we have for diagnostics that are really powerful. But next thing is object resolution. So now this is where you define what's the smallest object that can trigger an output. In light curtains, that is what we call the resolution as well. We generally have 14 and 30 millimeters. So here you can see hand protection. And if you're going to do area protection, then usually we like to go with the leg, because you're going to put it right at the base of a structure so that somebody walks in and triggers the output. Apart from that, one thing that I really like to tell customers, where there's always a little confusion, is that with safety scanners, there's two things. One is called a warning zone, which is simply where you can trigger an output from the LiDAR, but that's not going to be the safety output. The safety output is called the protective field. And that is how you select what the range of the scanner that you need. But you have to know what exactly you're going to use the LiDAR, like the scanner in what kind of application. Because if you see on the right side here, this protective field, what I'm telling you, 3 meters. So that's the maximum range of the safety scanner. But if I put it for a hand resolution, what you will see, the protective field drastically goes down. And hence we have to always be mindful about what exact range are we going to use the scanner for, and make the right choice based on that. Apart from that, there's one more setting which is really cool. It's called multiple sampling. Essentially, this what it does is basically you feed the hardware that the minimum number of times that it has to see an object during a scan to trigger an output. So now if I say 2, that means if during 2 scans it sees it, it's going to trigger an output. But if it's a very dusty environment, if it's challenging, then we like to go with a bigger sampling rate to avoid false trips. Okay, once you decide on the resolution, then we get into the fields. And this is how you configure the scanner. So let me zoom out. So the range on the scanner here, you can see this is the limiting zone. So this semicircle, actually more than a semicircle. So the horizontal aperture on this is 275 degrees. What that means is the scanner can see everything going from this end on the back side towards here and in front of it right here where I'm moving my cursor. And this small area is the blind zone. And this is the top-down view right now. And I have the scanner running in. So if I put my hand in front of it, try and notice where the yellow, sorry, the let's change the color. It's not good. Okay, so try and see that red thing coming closer to it. So that's my hand if you see that. So that's going back, right? So now that's the top-down view. You can delete this here 1 second. So once you have a scanner, you are going to say, I'm going to protect the area in front of the scanner. Let's say somewhere here, because I don't want somebody getting this close to the scanner. What we can do here is we can add a new field set. And once you click on the field set on the right side on the bottom, you do have the selection for a protective and a warning field. There's also something called counter field detection. It's let's save that for another webinar. But I'm going to do protective field here. And then you can select the multiple sampling rate as well as the resolution for the field set itself. So once I go here, I have multiple options. Now I can select the rectangular tool and just draw it based on that. Or I can select this circle here and draw it based on that. But my favorite one is obviously the polygon tool where I can create the shape that I want, right? And that's the beauty about this system, right? You're not limited to one thing. You can always change it as per the requirements of your application. Once you create the field, um, you can do different things. So let's say you also want to you want to make sure you have like a 2D drawing of whatever that system is going to look like. So you can also import that data as well in the system. So like for me, let's say I have a pipe bending application. I can just add that here. So if you see right here, so yeah, one thing is always remove the tool. I forgot. Okay, let's get back here. It kind of created a weird shape. So you can select it again. Select it here. Just create a new one. All right, so once you create that, you can select the image that you've put in there. So this is the 2D drawing of a pipe bending application. I know where that is going to be, and somewhat I'm protecting this front area of it. So I can do that as well with the scanner. And once you select the the protective area, you can go to your inputs and outputs. Now, this is where you can define how the I/O on the device is going to act. Your pin 2 and 4 already have your OSSD pairs, which is basically your safety output. Next is we do have a few more outputs as well as some inputs. And if you see right here, these are unassigned pin 5, 6, and 7. Uh, so I do have these 3 more IO options. What I can use it for, let's say I want to do a reset from the scanner itself, then I can put this here, drag it and drop it here, and then it's I can connect a reset on pin 5, right? Uh, let's say for output, it's more like if you want any kind of a lot of contamination happening on the device, you want to do predictive maintenance, you can use this output and just add it on any of the pins here. And then monitoring results. So if you have any kind of a warning field, you can add that to connect that to a monitoring result. And for that, how it generally looks like is like this. So you can have pin 5 here, but now you also want to create a monitoring field. So you go back, you add one more field, and I talked about the warning field, right? So I can just quickly create one more, and that can cover this area. So now that's my warning field, and I'm going to connect my IO on that. And then you can go to your monitoring cases. So when you create any kind of a configuration, you have to make changes on the monitoring cases, and all you got to do is click on this right side where you created the field set and pull it and drag it and put it here. Now, one thing that you have to do is the safety system. So now, which is basically the OSSD output. And if you remember, we already have it here on pin 2 and 4. And we will be using our output 5 for the warning field. So what we will do here is we will select one as OSSD and one for our warning field. And then if you have, let's say, a dynamic field switching applications where you have multiple monitoring cases, then you can add more monitoring cases here by just adding more of these, and then you can assign them different inputs to trigger them based on your static IO. But I don't have it here, so uh, once you do that, you can just go in your transfer and transfer whatever configuration that you created. The best thing about the software platform, which I really like, is the diagnostics. Now, if I go to the data recorder, and obviously I have to read from the device, I don't want to transfer anything. Let it do its thing. Okay, so it's back to the settings that I had initially. Now, when I go to a data recorder, I can actually have a live feedback of how the electrical outputs are actually performing based on the readings of the safety LiDAR. So again, let me zoom out or maybe zoom in here. So if you see my hand coming in, now watch for the OSSD pair 1, which is also our cutoff path. And these things, both of these outputs, it's actually the same thing, just represented by different names. It should turn low at every trigger. So if I put my hand in here, and you will notice that it went low. And if I put my hand back out here, let me do one more thing here so it makes more sense. So you can see the hardware itself. So now this right here is the scanner, okay? And if you see, that's how I'm interacting with it. So I put my hand closer to it, and the safety output goes off. So this really helps you when you're configuring the device so that you can actually see what is happening here. Now, next thing, what is really cool and useful about the tool is the event history. So if you read from the device, it can save up to 150 of the last events that ever happened on the device. And you have both the images of the LiDAR as well as the point of infringement. So now if I click on any point in the field here, it actually shows me the exact mirror image of what it saw, how the infringement happened, right? So like this was my hand right here, and that came close to it and it triggered it here. What happened here? So now that's a different one. And then you just don't have to blindly see it, right? You can go to the event tab and you can actually have a timestamp of it, so exactly you know when did that happen. And if you remember on the slide deck, I was talking about this camera called the new SEC100, which is like an event monitoring one. This is where the power of that camera comes into picture with this device, where each of these timestamp infringements can also have their individual recording or a snapshot. So we can be sure of how the system is performing. And yeah, next thing is so message history. So so this basically tells you whatever happens on the system, all the last infringement, like if there's any kind of a big error, it gives you the code for it. And then you can always download this entire file and there will be like a hex code for it, for each kind of error that happens. And that helps us figure out how to fix it. So you can always save this. And then there's also contamination measurement. If you remember in the configuration here on the top, I told you we can have that contamination error as a signal output on any of the pins. What that would do is, so if you see, this is the live feedback. And if I just blind the scanner on one side, then it knows, okay, because generally if it's a normal object, it should come in the field, go out. If it's not going out, it knows it's dirty, needs to be cleaned, and that's what it says. So now if I press gently against it, you will see it's not like dark red or whatever. It's like yellow, orangish kind of. And that just tells you that it's still pretty smart, where it knows that I'm only going to trigger an output for a contamination when there's actual system error. And these things also repopulate. So you just saw it updated. So right now is what, 1028. Oh, we're getting close. So it told you, okay, front screen dirty, and then better clean it up, right? And on the bottom here, you can see, like I was telling you, we have a nice hex code here, which tells you what happened. Front screen is dirty, safety outputs turned off because of that. Solution, it's telling you what to do. And yeah, it's pretty powerful. And the last thing is the report tab, which is super cool. So the report tab, you can always save that as well. And it can also save as a CSV file. So for the message history, and it shows you the part numbers, what happened on the device, what application, how you configured it, what the fields look like, how you configured the IO for it, and then the device status at the time of setting it up, how contaminated was it, and then at that point of time, what were the last uh, infringement points, what time it happened, what were the error codes. And this can be just saved and kept in the cabinet. So if it's a new operator, they can just look at it and they have a good knowledge of what happened in the past. If they make changes, they can put a new file in there. And yeah, I think that is it.
Awesome. Great job, TJ. We actually did get a question in the middle of your presentation that I want to make sure we get to. And we are going to be opening up to more questions if anyone has any other burning questions. Someone asked, does it give you a safety signature that keeps changing when you make changes?
I'm not sure on that, because at the end, so the safety signature in terms of the OSSD outputs, that's what the dual channel monitoring is for, I would say, for redundancy. So that's the signature it does give. But if there's any other thing, I'll have to check on that. But I can definitely get back to you on that if we know whoever the participant was.
Yeah, this was Anil John Pernthil.
Yeah, that's a good question.
I made a note of their question already. Yeah, and also if you guys want to speak to your question at all, if you hit the raise hand button, I can allow you to speak if you wish. Not asking anyone to do that. There's also the Q&A box as well as the chat if you have any questions based off what TJ presented. Yeah, here. Let me let Anil speak. Maybe he can answer himself.
Yeah,
or
that better.
explain.
Yes.
All right, Anil, you should be able to unmute yourself.
Yeah, thanks. It was just more like if somebody changes like something in the device later on, and then you have an incident and you're able to, like, in safety programming, you generally have like a checksum. Oh, there is a checksum for
Yes.
configuration. I saw a moment ago. So I just wanted to make sure. And then can you lock it down? That's the other thing. And then
yes.
I know this is hardwired output, but is there like a, trophy safe, SIP safe version of this?
So, right, let me pull up, let me answer the first question. So you're right. You can set the password for it, which it will force you whenever you get from the factory. It's going to ask you for the very first time to set a password. And then for that, obviously, you can have different levels of it too, administrator, client, and hence you can lock it up. And next thing is, if anybody makes any kind of a change on the fields, right? If they just somebody wants to add or whatever, like I'm doing it. I hope that makes sense. So if I do that and I still say, okay, let me transfer this, it's going to ask me for the password. And so right here, it actually popped on the other screen, but so it is going to do that. And
can somebody factory reset it and then change settings and put it on? I'm just like being devil's advocate here.
Yeah, they'll need to know the password to do anything. They'll have to know the main password first of all.
Okay.
And even if after whoever does it, they'll have to input their password. So as long as the password is not out there, we're good. Let me share one more thing. So for your second question, just hold on 1 second. Let me. Sorry, I got a bunch of things running here. So it's going to ask you to verify too, right? Like whoever sets the new configuration. But let me go on the software platform. Okay. So that is the programming window. I don't know if you attended from the beginning and you saw that, but this is how the software platform actually looks like. And then, oh man, let me get back. Okay, so if I let's say right now to answer that question, for the nanoscan series, we do not have a Profi Safe variant, but we do have it for the microscans as well as the outdoor scan. We have it in 5 meter, 9 meter, as well as 4.4 meter. Oh, sorry, 4 meters. So we do have a bunch of those. Sorry, my Windows is acting up. I can't show you the. I don't know.
Yeah, no problem.
Yeah.
The only reason I ask is most of the time when you have an issue, it's sometimes like a loose cable, and in a safety system, it's very hard to do. Like, sometimes, if it's a machine running at night, somebody wants to, there's a loose cable, and then, you start tripping all the time. I was just trying to see if it's, direct like node on Profinet or either an IP, then you can say device disconnected. So that was just the one thing that I was kind of curious in general.
Yeah, I mean, for that kind of like it's a false strip, right? That's the concern, right? For the loose cable.
Yeah. Yep.
Yeah, and what I've seen with customers mostly is if you saw that the sampling data rate, that is where if the, sometimes that can help. If you know that a cable might fall off and that might trigger it, you can increase the sampling rate. But if you know it's gonna dangle in there, then to get that notification, we do have the ProfiSafe variant, so you can do that. And but for that also, these things are at the end of the day not so smart where they will know exactly what is happening, right?
Right.
They will just give you a trigger, and that is
Okay.
why I love this thing here. I don't know if you see it in the camera. It's the
Yep.
new.
I've heard about that camera. Yeah.
It's one of the most economical thing that SICK has really come out with. It's super. I mean, I'll do probably another webinar or something, but it's super simple to integrate and has like 6 GB of onboard memory with 5 megapixel resolution, and this can help you figure it out, right? Next
Right.
thing is probably having something like a Flexi Compact. I don't know if you guys have ever used this one. Because
Yeah.
if you have a nanoscan, what you can do is take one of the outputs and then use this Profinet gateway here, and then configure like uh, just route the information from that scanner, add that it one of the bits, and then just get that information on any of the bits that, hey, that triggered. But then this at this point it will become a diagnostic output, not a safety output, right? Because it's not over Profi safe now.
Right. Okay. Yeah, I was just trying to understand. And the camera integrating, because usually that is useful, like if an incident happened and somebody had e-stop and people want to like later find out what happened, how easily is that camera integratable into the system?
Yeah. So let me just show you how the right way to do it and how simple it is. So if you see the screen right now,
Yes.
essentially the camera has it does have digital input. So either you can just use the digital input, trigger the recording, like, for the clip,
Right.
which I'll show you how to do that. But other thing is it does have REST APIs, so you can always do it on the fly with the REST API.
Okay.
And essentially it's super simple. So if you see this field here, if I have IO here, I already know I want to. So now it depends on how you want to trigger it, right? So now I want to do with the safety output. Now I know if I go to my monitoring cases, I know this is my safety output. So apart from triggering my the safety the OSSD pair, I will also trigger one of the IOs. It's not happy right now because
Sure.
it needs.
That's okay. It's just a digital trigger.
Yeah, so now
Probably
it's happy because I just told it that this is what you're gonna expect there. So that's it. Yeah, digital output. You trigger it, starts the recording. Does have 6 GB of internal memory, so you can save a whole lot of images there. Recordings, obviously, it's gonna reformat after it's full, right? Like it's gonna keep deleting the last few things. So
Right.
it does have FTP, so you can just have a constant upload of that, and it also supports the real-time streaming RTSP. I think that's the protocol, RTSP.
Right.
Because how SICK has designed this camera is not just to monitor the events, but it's like an industrial format of a CCTV camera. So you can also at the same time have like live feedback if you need that.
Right. Yeah, I was just like, I thought there was a direct connection, so the event log from the nanoscan can be matched to the camera directly. But I mean, you can kind of trace it based on digital input triggers, but I wasn't sure if there was the data connection that'll go between the nanoscan and the camera.
Yeah, that so
But maybe
there is
that's
no,
like,
yeah.
it's maybe something in the future.
Yeah, probably. But right now you will have to match up the either, like if it's on the same timestamp, then that could be one thing. But yeah, you'll have to do that. Right now it's there's nothing streamlined where it just does it for you, kind of.
Okay. Thank you.
Yeah, sure.